Sounds good. All right. So good morning, afternoon, or evening. Thank you all for joining us for this entry in the SG Near Surface Student Subcommittee's Open Source Software webinar series. So today we'll be rejoined by Alexey Dobrovskiy, who is the CEO and Chief Technical Officer at SPH Engineering, which is a multi-product drone software company and UAV integration services provider. Since founding SPH Engineering in 2013, Alexey has introduced a number of solutions that are recognized globally, like software to manage drone shows and drone-based industrial product lines. Currently, Alexey is responsible for strategy management and development and liaises with a few main customers. Also spends a lot of time in the field testing SPH's solutions in real-life scenarios. For founding SPH Engineering, Alexey had gained over 20 years of experience in the software industry, graduated from one of the leading tech universities in Eastern Europe, and started his career as a software developer. Later, he acted as a senior project manager and team lead. The large team led by Alexey consisted of 450 specialists, which included a mix of analysts, software developers, Q&A experts, and consultants. The main focus was on custom software development for multiple industries, such as financial, insurance, logistics, and manufacturing, while project scale varied from tens to tens of thousands of users. So tens to tens of thousands of users. There you go. So today, Alexey is going to talking us as a presentation about my software Geohammer, which is a simple tool to quickly assess and process GPR data, as well as CSV data from various other sensors, such as magnetometers, metal detectors, gamma radiation spectrometers, and so on. So without further ado, Alexey, I'll hand it over to you for your presentation. Thank you again for joining us.
Thank you for introduction. It seems that I need to shorten my official bio. It takes too much time. So, little bit of background behind actually Geohammer software, because a few years ago it was not planned to introduce it. So company started, my company, SPH Engineering, started in 2013 with single product. It is still exists. It is still our flagship product. Name is UGCS, Universal Ground Control Software. But in 2017, we started to work with geophysical sensors. And we started with ground penetrating radars, after that magnetometers. And now we supply many different strange devices integrated with drones. Here are a lot of photos from our test fields and from our customers. Devices are very different: magnetometers, ground penetrating radars, sonars, even multi-beam and side scan sonars. And currently we have a huge mess of different sensors, different technologies, and zoo of processing software. So for every type of kind of data, we and our customers have to use different software packages. For example, for GPR, maybe most popular is Geolytics or Prism 2 and hardcore GPR slice. Different packages for magnetometers. So here's a list, I will not read it. But what all that software packages have in common? Usually they are very complex. And I remember my hard time when I started to use, for example, Oasis Montage. I spent months to be confident with the basic set of functionality what I need. I think it was good investments because I still use Oasis Montage and use it almost every day for kind of non-standard cases. when we have some problems of the data, when I need to try not very standard workflow of data processing, something special. But problem of such software packages is that they have the same complexity for all cases. For simple cases, for good quality of the data, or for the not so simple cases, you will need to go through the same workflow, which is overcomplicated and which was designed for the most complex cases, what should be handled by geophysicist or hydrographer who have to process data. Sometimes such software packages are pretty expensive, and mostly they are oriented for the particular sensor or particular technology. For example, it is very hard to find software package which will allow you to merge data from, for example, gamma radiation spectrometer and magnetometer and, for example, seismic. It is possible in some software like, Oasis Montage, for example, but mostly all packages oriented for the very particular sensors or technologies. We are as kind of independent vendor. We don't manufacture sensors. We integrate sensors with commercially available drones. We are very interested to make a full workflow as simple as possible. Because starting from beginning, we found that approximately half of our customers don't have geophysical background or background in hydrography or in some specialized area. They were drone service companies which want to expand their services portfolio to provide more profitable services to their customers. Often they don't, one more quite big group of customers who used terrestrial sensors like handheld metal detectors, and they want to use also drone-borne sensors. But here is very different story. You need to plan flights, you need fly pre-planned mission, you need to collect data, and after that, process the data and make interpretation. With handheld devices, you often have some indicator in device, and if you are looking for metal, for example, for an exploded ordnance, you make decision right during the data collection. So here is situation very different, and such kind of potential customers also need very simple tools which can be employed in not in months but in days actually. So it is how we came to an idea to create Geohammer to have software actually as simple as possible applicable for the most standard applications like use of magnetometers or electromagnetic induction tools to find metallic objects, not only unexploded ordnance or landmines, but also for archaeology or to search for underground utilities or something like that. But such tools should be also useful for in-field data assessment and quality assurance, at least basic, because every service company who provide magnetic geophysical services, geophysical survey services, had situations when field team collected the data, they left the job area, and in some time after that, geophysicist who processes the data will find the data is not good quality, and it will be good to recollect the data again. So expenses will be much more lower if field team, which usually doesn't have high qualification geophysicists, at least in the field during the data collection, may use some simple tool just to check that data has acceptable quality. So Geohammer supports virtually any kind of CSV data stored in CSV format, comma-separated formats, or similar formats. And Geohammer requires as mandatory just a few columns of data in files. It should be time or timestamp, coordinates, and some value measured by sensor. Geohammer also supports SIGWI files from echo sounders and ground penetrating radars. 99% of Geohammer code is open source. Here is link. 99% we have in paid version export functions. I will show you the difference between fully open source version and commercial version. And it implements very minimalistic or mandatory set of functions required to process data. What I mean, it is low pass filtering, gridding, of course, GNSS time lag compensation, which is normal for current airborne systems and not only airborne actually. We also implemented a running median filter to highlight anomalies. It is most simple and straightforward filter for such purpose. And for the complex cases, we implemented possibility to start Python script from Geohammer to implement some not standard or tricky processing, which is not implemented in Geohammer itself. So results of Python scripts immediately after it's finished are visualized by Geohammer. Actually, that's all. I mean presentation. So I will show you how Geohammer works. So I have a few data examples. First data set is recorded by Sensor-1 magnetometer over test field with unexploded ordnance and landmines. So to add data files to Geohammer, you may use drag and drop, or you can open the files in traditional way. So here, immediately after file import, we will see a data track over the map, over satellite map. And first step usually is to cut unnecessary pieces of the data. Because in case of airborne surveys, for example, usually sensors log the data all the way between takeoff and landing. I use selection tool and yep, one click, and I have only lines. Here we have all data columns from file, and TMI is total magnetic intensity recorded from the sensor. We can zoom in. And in most cases for airborne sensors, we will see some noises. So for CSV data, for one-dimensional data, we can use low pass filter to remove high frequency noises. And main source of such noises, usually it's the drone itself. We can see filtered data. And next step is gridding. So here for the grid, we have just two parameters. It is grid cell size on surface in meters. Here I will use the grid size, cell size 10 per 10 centimeters, and blanking distance. It is how far from survey line we should extrapolate grid. Usually it should be something like distance between survey lines. Apply. And we have a grid of total magnetic intensity measured by sensor. So normally from many magnetometers, we will see stripes in gridded data. It is expected, actually, it is because of heading error of magnetic sensors. Easiest way to remove heading error in case if we are looking for quite small magnetic anomalies of high intensity is to use running median filter. Here we need to specify the length of the filter in measurements. So we will apply the running window for every 1000 measurements. And we have one more data series called anomaly filled by that filter. It is displayed in different color. Line is, I hope it is visible, green line. So, and we need to rebuild the grid. Adjust palette. Yeah. And now we have magnetic anomalies map. If result is good, actually we can stop data processing, but and start, for example, marking of anomalies if we need to have coordinates of anomalies, for example, for excavation. Marking of anomalies is very simple. We can double click on anomalies. We can estimate using statistics window how intensive is anomaly or its range or amplitude. If we decide that that anomaly is worth to be marked or to excavate, we set flag. That anomaly is huge. And repeat that process for all anomalies what we want to mark. Marked anomalies marks are stored in source file. Geohammer will add additional column with the name marks to the CSV file. It will be stored if I will click button save, but also we can export marks to KML file and use that file in any GIS software or in handheld GPS navigator. A couple of more useful functions of Geohammer is time lag compensation. Here that data set is quite good quality, but I will just show how it works. You can see that our oblong anomalies became not regular, and I can play with time lag. Yeah, much better. And maybe almost last point in the standard workflow is quality control. Standard problems in with data collected using geophysical sensors, not only drone mounted but also from the ground. I mean, using handheld sensors or cards, is the very different distance between survey line and specific for airborne survey variable elevation of the sensor over ground. So that's the two typical problems. And here in Geohammer, we implemented very simple tool to check the distance between lines and elevation of the sensor over ground. So here, as I remember, it was intention to collect the data with maximum distance between lines half of meter. And altitude, let me check. And altitude, yes, should be 1.3 meters by altimeter of the drone. So I can enter here required distance between lines and acceptable error, and also required altitude and acceptable error, and click apply. Geohammer will highlight using different colors problem spots. Yellow is where distance between survey lines is bigger than, in our case, 50 centimeters plus 20, 70 centimeters. And also it will mark in red points where altitude is above 1.3 meters plus 10 centimeters. We also can export that image with marked problem spots and use that image. It will be JPEG image, and use that image, for example, in Hellhead Navigator to recollect the data using handheld sensor, or check the places using handheld sensors, for example, if we are looking for UXO, unexploded ordnance. Or if we have a lot of such spots, we can import geotagged image with marked spots into flight planning software and plan additional flight to collect data here, just here. That's a basic workflow. But what is also interesting in Geohammer? We can import into Geohammer multiple files of different kinds. I will add here data collected over the same test range using ground penetrating radar. Oops. Something wrong? No. Remove background and increase contrast. So for GPR, we have actually two processing options. Just remove background and manipulating the gain on screen. Why it is useful? Of course, you can check the quality of GPR data right in the field without use of any complex software packages. My strong belief that if you don't see anomalies in GPR data without any extra processing steps, that means that most probably you need to repeat data collection, or GPR will just not work in that area. For example, it is covered with clay. In most cases, for such tasks like utilities detection, you should get good anomalies. You should see good anomalies after two very basic processing steps: background removal and gain manipulation. But in Geohammer, what is also useful, we can check in case of magnetic anomalies what we have in GPR data. For example, here is, as I remember, landmine. We can check magnetic anomaly, and we can check also if it is visible in GPR data or not. It looks not visible. What is here? Yeah. Here is some small magnetic anomalies, two dipoles, and here we have a quite good GPR anomaly. So that tool can be used for the kind of joint interpretation of data from different sensors, very different sensors. So it was a basic functionality. I have more interesting examples. Here is a data set recorded by a gamma radiation spectrometer. From vendor, you will get software called Gamman. I want to show you its screen. It's here. Quite complicated software. It allows to do anything with gamma ray spectrometer data, but in most cases, end user will need to see just different spots of soil on the ground, actually. And for such purposes, very simple tools like Geohammer are more than enough. I just imported using drag and drop file with data recorded on board of sensor data recorded, and just a grading is enough to understand where we have a different soil or surface composition in our test field. Actually, here is asphalt road. Here are two spots filled with the sandy soil and black earth. It is our test field. Our office is here. So if you need very straightforward, very basic data processing or data visualization, actually, as in that particular case, Geohammer is enough. Geohammer is enough. And also, of course, you can, that sensor logs total counter and also concentration of different radionuclides. So we can grid concentration of different nuclides. Uranium, kali, thorium, and so on. One more data example is also recorded using magnetometer. We need to wait a bit because with video conference in parallel, my laptop is almost melting. It's a quite large area of our kind of house lake. It is a few minutes drive from our office. Lake is 150 meters over the center of lake. Why we did actually here magnetic survey? It's an interesting story. We did full bathymetric survey of that lake. I will show you 1 second. Here we did a full bathymetric survey and found a lot of different, I would say, irregularities on the bottom. So in 3D, it is much more obvious. And that ignited my interest because about almost every second lake in Latvia, there's a legend that here is airplane or tank from World War II. So such places on the bottom looks interesting, and we decided to conduct also magnetic survey here. So the same more or less processing sequence, low pass filter. We can build a grid. Oh no, 10 centimeters for such large area is too much actually. Not a good attempt. Okay, I will just restart Geohammer. So future request to implement cancel button for long operation is already registered, is already in work. So low pass filter and grading with more reasonable parameters, 0.5, 5 meters, okay. So magnetic map based on total magnetic intensity from the sensor has the same issues as in previous example. We have stripes because of heading error of the sensor. So I will apply the same running median filter. And I need to switch to TMI anomaly field. And again, manipulate range. So here, we can see that there are a lot of magnetic anomalies in lake. But unfortunately, they are pretty weak. Here, for example, is around 7 nanotesla amplitude, and it is definitely not tank and not an airplane. Interesting that here in that approximately that point is sunken boat on bottom of lake. It is around 8 meters in length. I already closed the multi-beam data, but doesn't matter. But most probably that anomaly is not from that bot because it is actually much more smaller than anomaly. And what we see here, we actually don't know. We passed all the data to local municipality because they plan cleaning of the bottom. But interesting. What is maybe last functions what I want to show? So As we don't want to implement a lot of functionality inside of Geohammer, outside of pretty basic, straightforward standard set, we implemented kind of plug-in mechanism, and as plugin, we use Python scripts. How it works? I will not start that script because it makes pretty complex task. It implements correction of the magnetometer data using vector components plus altitude plus latitude, longitude, and so on. So it will work approximately 10 minutes on my laptop. So if I will start it, Geohammer will create a file, temporary file with the copy of data, and start script passing file name and all the parameters to the script. If script will finish without error, Geohammer will load data saved by script from the same file instead of data loaded in memory. Very simple. How to connect script to Geohammer? Script should be placed into directory scripts, subfolder scripts. There are absolutely no some specific requirements for the script. Just any Python script which can process your data, and it should, the only requirement, it should accept file name. And also script can have additional parameters for the command line. Also, second mandatory file here is a JSON file which describes Python script for Geohammer. File name, display name, and all parameters. So, script can be debugged and tested outside of Geohammer, and after that, it can be used as part of Geohammer workflow. One quite standard question is how to make Geohammer to read data formats or files which are not included into standard distributive of Geohammer. Very simple, actually. Geohammer uses data templates or format templates, and I can show you most important parts of such templates. Name, time, and first important part is a regular expression to detect that file with data is suitable for the processing using that template. When new file is added to Geohammer, Geohammer will apply that regular expressions from all templates to that file, and if it will find matched template, it will decide that so that file is corresponding to that template, and all metadata from template should be used for that file for processing. Next, we can declare additional validation rules. You saw how Geohammer implements quality assurance, quality check for the distance between lines, and actually for the distance between measurement points, not for the lines, and for the sensor elevation. But here you can declare additional data validation rules, because many sensors reports states of the data or own health. And also declaration of parameters or data mapping. For Geohammer, mandatory parameters are coordinates and data time or timestamp. All other parameters, like a lot of declared parameters for in that template, are actually not mandatory. Of course, you need to declare at least one parameter with sensor value. And last bit is about export functions. Absolutely all what you saw is available in free open source version. But there is just one block of functions called export. It is available in paid version only. It is export of GeoTIFF colored image for the grid. I will show you results. Also, GeoTIFF asset data, it will be not colored, but every pixel in GeoTIFF will have the same value as grid. And also market positions. KML. So now we can use KML file in virtually any JS system or handheld navigator. We can also use GeoTIFF files. Click. And yeah, of course, if you want to use grid data, you can use data, GeoTIFF file with data. That's the only difference between fully open, free, and commercial license of Geohammer. But everything what you do during data processing, I mean filtering, GNSS time lag compensation, even marks, are stored into your files. If I will click Save, all results of processing will be stored in CSV file. So it is field column with calculated anomaly and marks. So all processing is free, visualization is free, and yeah, only export of resulting artifacts, generated artifacts, is available in commercial license. What are restrictions of Geohammer? First, we are trying to make it as simple as possible. We are trying to avoid approach with the project and layers. Because actually for the simple situations, it just adds complexity. But in case if your project, if your job, as a result of survey, you will get a multiple of different files, Geohammer may be not so convenient as, for example, for Oasis montage. Second restriction, Geohammer uses in-memory processing. So there's a kind of physical limit for size of files which Geohammer can handle without additional discomfort for the user. In that file, as I remember, I have a few millions of records, and it is still okay. But if we need to process magnetic data, I don't know, for the large area, better to use more complex tools, or you will need to process the data flight by flight or area by area. I think that's all. That's all from me, at least planet content, and yeah, I am happy to answer questions if we will have them.
Excellent. Awesome. Yeah, thank you, Alexey, for the demo and for the kind of comparison between the functionalities of the open source version versus the paid version. We have a few questions in the chat that we can go through. If anyone else has any questions while we're going through these, feel free to either drop them in the chat or in the Q&A window on the top there. I think the first question was just kind of getting verification on the data format that you're importing, such as standard CSV, right, with timestamp, lat long, and then signal parameter.
Is it the Excel data of which kind? So yeah, it is not Excel data. It's just on my laptop. I assign it CSV format for Excel. So Excel will pop up if I will double click on CSV files. So it is CSV, separated values format, but actually not only comma, because in template you can specify any format. So tab, space, any format. Of course, Geohammer will not be able to read some proprietary data formats, for example, from Geometrix Megero, but in such cases, for example, for Geometrix Megero, you can use Geometrix Survey Manager, as I remember name of utility, to export data into CSV. And for that format, we have a template for Geohammer.
All right, we have a question here from Arya, how to filter magnetics data from dipole to monopole.
Okay, let me show you my screen. So it is kind of work in progress, but maybe you notice it here, a FLAC analytic signal. It works not so good at the moment. Yeah, not very good on many data sets. But actually, it is to answer on your question. From dipoles, make monopole signal with actually to generate analytic signal.
It's a question from Yomi about whether or not Geohammer allows for depth migration or FK migration for
No.
GPR profiles.
No, even not Planet. Because for GPR data, if we will start to implement such functions, we will reinvent the, I don't know, Geolytics or GPR slice. So again, Geohammer is not to substitute full-blown software packages in all cases. Maybe, or most probably, we will add into Geohammer capability to specify dielectrical permittivity and to add scale in depth values in meters or centimeters. Now we have samples and nanoseconds. So most probably we will add that, but not complex functions. Can we able to identify the depth of the pond or lake using this application? The question is using what sensor? If you have CSV file with data from echosounder, yes. Answer is yes. If you will use data from I don't know, GPR, answer is no. I can show you how it looks. I have a lot of data sets. 1 second, I will share my screen. I need data from here I have two data sets. One is collected using echosounder, and second is collected using low frequency ground penetrating radar over the same river, over the same line. Oh, okay. Trust me, here is river. And here is reflection from bottom in ground penetrating radar. In ground penetrating radar data. Yeah, very interesting that here we even see sub-bottom reflections. And from the same place, we have echosounder data. Altitude is not interesting. Yeah, depth. Yeah, now they're more or less in sync. So for echosounder, we have depth measurements in meters. It's here is 2 meters. So in the same point here is bottom reflection, also around 2 meters. So it depends on what sensor you use. If it reports meters, you will see meters in Geohammer. If it reports some values like actually nanoseconds as ground penetrating radars, at the moment Geohammer will not recalculate your units into depth units.
Question
Yeah,
asking about base station correction for
station.
magnetometry.
We don't plan to implement base station correction. You need Oasis montage for that. So I can explain why. first, we don't want to invest millions, really millions, to reproduce, I don't know, 10% of functions of Oasis montage. Second, montage is very good. If you need functions like base station corrections and so on, most probably you are doing surveys for the minerals exploration, for geology and so on, and you need quite sophisticated complex processing workflows. It is no sense to implement them in Geohammer, but something can be implemented, for example, in Python scripts, if you want to have something custom. But out of the box, we don't want to have base station correction, reduce to pole, different filterings, so on. No. Yeah, and actually I answered on the second question about reduce to pole. No, we don't have reduce to pole. And for the straightforward application of Geohammer as data interpretation tool, I mean for the detection of very near subsurface targets, reduce to pole doesn't have any sense, absolutely. Maybe you will have a correction for a few centimeters during interpretation, but doesn't have any sense. Can we use this software only for magnetic data processing? Answer is no. I demonstrated ground penetrating radar. I demonstrated data from gamma ray spectrometer. I can show you data from electromagnetic instruments and so on. So answer is Geohammer can be used for any data stored in text files with data columns, with any separators, and for SIGY files.
I'll say, out of curiosity, for the intention of using Geohammer for kind of like joint geophysical kind of like interpretation, are there any plans to implement any kind of just like, inherent statistical metrics to compare these, joint geophysical methods, or is that more on the user to develop a script to put into or to be used in Geohammer?
Actually, it is for what we implemented support for Python scripts.
Okay, cool.
Because such joint interpretation of the data is very application specific. Mm-hmm. You need to know what you are looking for. So if you are looking, for example, for unexploded ordnance, you know how your magnetic anomalies should look and how GPR anomalies should look. And you can easily implement at least semi-automatic data interpretation using data from two sensors. But in common, the task doesn't have any answer, right? Because it's very application specific. Mm-hmm. And Python scripts are answer. You can do anything with your data. And for the Python, why we selected Python? Because for Python, it's kind of Fortran. I don't know, guys. Do you know what is Fortran?
Oh, yeah.
Yeah. I started my education. When I started my education in university, Fortran was still very popular. So currently Python is new Fortran. It has a lot of libraries, a lot of ready functionality for almost any kind of data processing, machine learning, blah, blah, blah. And we make a gate for that functionality. We made a gate. Yeah.
Gotcha.
One more question. Can we use it for seismic data processing? Honest answer, I don't know. Because I never tried to handle seismic data. If it is stored in SIGY, as I know, it's most popular format to store seismic data. And if coordinates and, I don't know, traces headers are in the same places with the same semantic as expected by Geohammer, at least you can visualize the data. But I have absolutely zero experience and zero knowledge about seismic data processing, so I cannot answer. Most probably no, because most probably just background removal and game manipulation is not enough. But maybe I'm wrong, I don't know. We are, with our drones, we are very far from seismic data. Unfortunately.
That'd be something though, you know.
Yeah, unfortunately, because 90% of the money in geophysics are going to oil and gas for seismic surveys. It's a reality. So that's all. Thank you so much. Thank you so much for the listening, for your questions, and for the arranging webinar.
Absolutely, yeah. Thank you so much for your taking the time to talk about Geohammer, and for answering these questions. So if anyone else has any last minute questions, feel free to drop them in. But otherwise, thank you for coming to this latest entry of the open source software webinar series. One being a combination of the SEG Near Surface Student Subcommittee. I always have to remember the full name of that. Thank you all for attending, and thank you again, Alexey, for taking the time and for the great presentation and demonstration.
Thank you. Bye.
Thanks.